Okay, so we've taken that 4 to the 5th times 3 to the 5th and raised it to the negative 1/5. We've kind of broken into two pieces. Now I can use my power of a power rule and take 4 to the 5th raised to the negative 1/5. I'm going to multiply those. What's negative 1/5 times 5? If I have 5/5, that's 1, right? So this is raised to the negative 1 times 3 to the negative 1. Any questions on that step? Now I can combine these because they've got the same exponent. So I can rewrite this as 4 times 3 raised to the negative 1. What's 4 times 3? 12 to the negative 1. And then that is just, remember, if it's to the negative 1 power, I can write it as 1 over 12 to the positive 1 power. Okay, so this is, we're using rules for exponents here. Notice that I don't have the same base, and I don't have the same exponent, so I can't really combine anything on the inside. I'm going to have to use the same technique as I did in number 2. I'm going to have to you kind of think of it as distributing that 2 over those two fractions. So 6 to the 1/2, oh no, oh no. All right, 6 to the 1/2 squared, what is that going to be? 6 to the 1. Okay. And then what is 4 to the 1/3 to the second power? 4 to the 1/3 squared. In other words, what's 2 times 1/3? 2/3, right? Yeah, I think I can. If I can simplify 4 to the 2/3 even further, I want to do it. But remember, I don't know how to handle something, raised to a fractional exponent. But if I change it to a radical, then I know how to handle it. So what does that change into, that 4 to the 2/3? What's my root? Right, yeah, 3. And then 4 squared. Okay. And if I'm taking the cubed root, I'm looking for sets of 3. Unfortunately, it doesn't quite look like I've got sets of 3, but I think we can break this down a little bit further. Isn't this 4 squared? Isn't that 4 times 4?
Yes.
Still no sets of 3, but if I go further, isn't 4 2 times 2? Yeah, and that other 4 is 2 times 2 also. So now do I have any sets of 3 of anything?
Yes.
Okay. Yeah, I've got a set of 3 2s right here, right? So I can take that out in front. So this is 6 times 2 times the cubed root of what's left over?
2.
Just 1 2, right? I took out this set of 2s and put it right here. So I'm left with just 2. We can rewrite this as 12 times the cubed root of 2. Well, I'm just going to write the first step and yell at me if it's too crazy, okay? But hopefully it won't be. I'm just going to write it, and you tell me if you see what I did. Oops, change the number. 42 over 6 raised to the 1/3 squared. Take a second and tell me if that is... Here's why that helps me. What's 42 divided by 6?
I have a question. Why is the 42 and 1/3 in the picture? Why is it in parentheses?
It was the only way I could make my math writing program set up in that format. I apologize. It doesn't have to be in parentheses. It probably won't be in the English. What's 42 divided by 6? 7 raised to the 1... Well, I don't want to do that. Raised to the 1/3 squared. What's 7 to the 1/3 squared? In other words, what's 2 times 1/3? 2/3, yeah. Okay, so our final answer is 7 to the 2/3. We know this won't break down any further and this won't reduce because 7 is a prime number. Can I rewrite the nth root of a times b? Can I write that as a times b raised to the 1 over n. Isn't that true? Yeah, it is, right? And then using one of my exponent properties, can I say that that is a to the 1 over n times b to the 1 over n? Is that true? Okay, good. Yeah, I think all that's true so far. And then a to the 1 over n, isn't that the same as just the nth root of a? And then b to the 1 over n, isn't that the nth root of b?
Yeah.
Oh, hey, look. This thing right here is that thing. Yeah, what a coincidence. So really, these are just exponent rules kind of rephrased in terms of radicals. Radicals are just exponents. So that's why this rule works. Right. Any questions on the cube root of 12 times cube root of 18? All right, well, I could try and simplify cube root of 12 first. I won't be able to. Cube root of 18, I won't be able to simplify that either. But I think using that first property, I can rewrite this as the cubed root of 12 times 18. Then the question becomes, how do I simplify it from here? Now, one method that you could do and would absolutely work is you could go figure out what 12 times 18 is, put that thing in the box. I think it's easier if we just break down 12 and then break down 18, kind of on their own. So here's what I'm saying. Instead of multiplying 12 and 18 together, let's take 12, put that in the box, and break that down first. Okay? So what do you want to take out of 12?
2.
All right. What's 12 divided by 2? 6. What do you want to take out of 6? 2. And then 3, and then we'll take a 3, and we're left with 1. Okay? All right. So 12, then, I'm going to replace with 2 times 2 times 3. Okay. Now, let's break down 18. So I put 18 up in my box. What do you want to take out of 18?
2.
Okay. 18 divided by 2 is 9. What do you want to take out of 9?
3.
Okay. 3 and 3 and 1. So in place of 18, I can write 2 times 3 times 3. Taking the cubed root of this number, so I'm looking for sets of 3. Do I have sets of 3 of anything? Yeah, I've got a set of 3 2s, and I've got a set of 3 3s. What's 2 times 3?
6.
6. Okay. So that mess, that cubed root of 12 times the cubed root of 18 is actually just 6. Actually, I kind of, when I took the picture, you've got the first step there already. But we started off with this fourth root of 80 over fourth root of 5, and then we use that second rule, the quotient property. We said, let's just make that the fourth root of 80 over 5. Why is that helpful? Well, because 80 over 5, I can figure that out pretty quickly. What's 80 divided by 5? What is it? I don't think it's 6, is it?
No.
Oh, 16, okay. Okay. So then we have the fourth root of 16. What is the fourth root of 16? Nope. Fourth root of 16 is 2, right? Because if I break down 16, I've got 2, 2, 2, 2, 1. So that is the fourth root, fourth root of 16. I'm looking for groups of 4 of anything. I've got a set of 4 2s, so that's just going to be 2. The index in my little diagram is A. Okay, so this is my index. Okay. My base is this x to the b right here. Now, I called it the base because I think because radicals can be phrased as exponents, so this ends up being the base. Your book might call it the radicand. So this x to the b is the base, or you might see it as the radicand. It's whatever is underneath the square root. Okay. I would. I notice that the index on both radicals are the same. I'm taking fourth roots. The number underneath the radical is the same also. It's 10. So what I've really got is 1 times the 4th root of 10 plus 7 times the 4th root of 10. And so I can combine those just like I would like terms. Okay? So since those are like terms, what is 1 plus 7?
8.
8. So this is 8 times the 4th root of 10. Yeah. All right, number 2. Now, this was kind of a bad example because the square root of 3 squared can be simplified, but pretend that you had something that couldn't be simplified. If I have 3 times the square root of 3 squared minus 8 times the square root of 3 squared, do I have like radicals or like terms?
Yes.
Yeah, I do, right? Because I've got the square root of 3 squared and the square root of 3 squared in each term. So I can just go 3 minus 8. What's 3 minus 8?
5.
Negative 5 times the square root of 3 squared. Okay, which you can simplify further, I understand. If I had 3 squared underneath the first radical and then 3 cubed underneath the second one, wow, you can't see that. 3 cubed underneath the second one, would I have been able to do that step? No, I wouldn't, right? Because then they wouldn't be like radicals. I have something underneath the radical would be different. Cubed root of 64 times y to the 6th. I'm going to break this up into the cubed root of 64, guys, times the cubed root of y to the 6th. Right? Are we okay with that step?
Yes.
Okay, I think that's going to make things a lot easier. Here's y. Cubed root of 64, I can break that down. 64, cubed root of 64, can we figure that out real quick? What is that?
What?
Cubed root of 64.
Oh.
What number multiplied 3 times gives me 64? 4, okay? So this is 4. We could have broken it down and taken out the pairs of 4s, whatever, that would have been fine. Cubed root of y to the 6th. Well, doesn't that mean that I've actually got like 6 y's lined up here underneath the cubed root?
Yep.
And I'm looking for sets of 3. How many sets of 3 y's do I have? 2. So isn't this then just y squared? All right, and I'll rewrite that so it's a little nicer. 4y squared. All right, next one. 27x cubed y to the 12th to the 1/3. I can't simplify anything in the parentheses. That's kind of the first thing I look for. I can't do it. So I'm going to break this up into 27 to the 1/3 times x cubed to the 1/3 times y to the 12th to the 1/3. So this is a situation in which we probably don't really want to go to radical notation because I think it's going to work out pretty nice. 27 to the 1/3, that means the cubed root of 27, this is one that we should probably have memorized. The cubed root of 27 is what?
3.
It's 3, right? Yeah. So this is going to be 3 times, what is 3 times 1/3?
1.
Just 1, right? So isn't this just times x? And then 12 times 1/3, because we've got power to a power. What's 12 times 1/3? 4, right? Or 12 divided by 3. So this is y to the 4th. This will be fun. The 5th root of 4 times the 5th root of a to the 8th power times the 5th root, oh yuck, that's ugly, 5th root of b to the 14th power and times the 5th root of c to the 5th power? Oh, yuck. Okay, any questions on, I simplify the 5th root of 4? I would need a set of 5 of something, right? 4 factors into 2 times 2. There's no way I'm going to get a set of 5 of anything. So the 5th root of 4 stays by itself. Don't go anywhere, 5th root of 4. Be good. Okay, 5th root of a to the 8th. Well, remember, a to the 8th means I've got 8 a's lined up there, right? I'm looking for sets of 5 a's. So if I took out one set of 5 a's, how many a's will I be left with on the inside of the root?
3.
Yeah, I'll just have a cubed, right? So make sure that you be careful. Fifth root of b to the 14th. Well, that means I've got 14 b's lined up, right? I'm looking for sets of 5. So if I take out, well, first of all, how many sets of 5 b's will I have? Yeah, I have 2 sets of b's. So instead of having just one b out in front, let's go to a different color here. I'm going to have b squared, right? Because I'm taking out 2 sets of b's. Right? If I take out all 10 of those b's out in front, those 2 sets, what's that going to leave me with underneath the radical?
B to the 4th.
Yeah, b to the 4th, right? Leaves me with 4 b's underneath. And lastly, hopefully the easiest one, what's the 5th root of c to the 5th? It's just c, right? I've got 1 set of 5 c's. All right. Now, mathematicians are picky. This is kind of ugly. Can we make this look a little nicer? I think we can. And here's what we're going to do. We're going to take that a, that b squared, and that c and put it out in front. Okay? So we're going to make this look a little bit cleaner. And then we're going to put underneath the 5th root everything that's still under the 5th root. So if it's under the 5th root, it's going under 1 5th root instead of 3 separate ones. So we have 4 times a cubed times b to the 4th. That's our final answer. Next one. Now the first thing I check is, can I simplify this stuff underneath the radical at all? M to the 4th, n to the 8th. Can I simplify that at all? No. I've got different bases. I've got different exponents. I don't think there's anything I can do to that. But I can rewrite this as the 4th root of m to the 4th divided by the 4th root of n to the 8th. Okay? And I think that'll be really helpful, because the 4th root of m to the 4th is just what? M, right? Okay. The 4th root of n to the 8th is just what?
N squared.
N squared, right? Yeah. I've got 8 n's lined up. I'm taking out 2 sets of n's, so I've got n squared. And that's it. Just m over n squared. All right, here we go. I want to simplify this thing. So the first thing I do is I look at this 8xy to the 1/4, and I should see pretty quick that there's nothing I can do to that. I can't make that simpler at all. So that's going to have to kind of leave, we're going to have to leave it as it is right now. But if I look at this other thing, I think that I can simplify this a little bit. How might I simplify this? Not distribute the 3, right? Because it's in that parentheses of the squared term. But can I get rid of the squared? Yeah, let's do 3 times, what is x to the 1/2 squared?
X.
Just x. And then what is y to the 1/8 squared?
Y to the 1/4.
Yeah, exactly, 1/4. So it's y to the 1/4. We left the second thing alone. So we left it as 8xy to the 1/4. Okay. And now this is great. It went from kind of an ugly problem to a not so bad problem because I have like terms. Now I've got 3 times xy to the 1/4 minus 8 times xy to the 1/4. So I can combine those terms. What does that simplify to?
Negative 5.
-5 times
XY to the 1/4.
xy to the 1/4. Okay? Yeah, and that's it.